It's increasing also here. Okay, entonces my function is increasing, this function is increasing in the following interval. Let me copy where? I suppose que here. Okay, from 1 to 2 interval. Okay, that one. And from 5 to 5, so union 4 to 5. Never include the endpoint, because the endpoint normally is the transition. O sea, es the point que the behavior change, increasing to no increasing or another thing. Okay, now decreasing. What is the idea of decreasing? Well, you have exactly the same. You pick one couple of x. X2 is bigger than x1, but we have completely opposite direction. So the y is smaller. It's a decrease. It's going down. Decreasing in this case is obviously that part. Roller coaster of the car of the roller coaster is going down. So this is increasing I, capital I, and decreasing F from 6 to 7. Decreasing. And constant is when you pick two values of the x and the y stay the same inside the interval, of course. It's constant. And constant represents in this interval like a horizontal line. In this case, well, sorry, decreasing is, let me change the color, what's the yellow part? Decrease. Decrease in yellow, increase in green. And constant, well, is the interval constant from 2 to 4 and 5 to 6. Okay, because the roller coaster car don't change UI. It's constant. Y value stay the same. And it's a constant. Constant, let me select using another color, maybe blue. Constant. So constant is blue. You understand this very well or no? Entonces, well, what about transition point? Well, sometimes it's complicated, sometimes no. Suppose in one arbitrary example in which you have a function like that, increasing, stop increasing and decreasing. This peak of the hill is called local minimum. And suppose decreasing, stop decreasing, no anymore, and increasing now. This point is called local maximum. Si you say, bueno, professor, what definition of local minimum, local maximum? Not necessarily the higher value, because suppose you have a curve like that, boom, 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 boom. So this is local min, local max, sorry, I make a mistake. This is local maximum. Okay, here is maximum. This is minimum. So the peak of the hill is local maximum. And the deep part of the valley is local minimum. I try to explain what the reason is local and not absolute. Absolute is the maximum y. For example, this is local max. This is local mean. This guy maybe, I don't know, I need to analyze the entire domain. It's absolute max. And suppose that this is going down more. This is the absolute mean. Of course, I suppose that the domain start here and stop here. I have no more function in this part. No, no, si es from negative infinity to positive infinity, entonces I cannot affirm 100% que this is absolute. I need to analyze the entire domain, but it's okay. Entonces, the most important is not the local maximum, local minimum, is the interval in what the function is increasing or decreasing. Okay? Entonces, bueno, professor, what is the definition? So you define in few words, what is the local maximum and local minimum? Okay, is when the function increasing, and stop increasing and start decreasing. It's a transition between increasing, decreasing, is local maximum. And similar, when it's decreasing and stop decreasing and start increasing, is local minimum. Got it? You understand very well this or no? Okay. Now the last concept I want to reinforce it. Well, reinforce it? No, explain, because I never explain. Is the I say something but not totally complete explanation. Is the when the function are even, boom, comma, odd, boom, or neither. Okay. By the way, I need to explain that even and odd are special. A special case. However, neither is completely no special, it's ordinary case. Okay? So this is a sophisticated guy, even, odd. Okay? How you recognize it's even or it's odd? Well, the definition is clear. Look, so you have a function and you perform reflection like that. Reflection when you replace x for negative x, and suddenly happen, okay, nothing happened, stay the same, it's because this function is here. Example to understand this. The classical, the function x squared. The function f squared, the function is a parabola, is f of x equal x squared. However, you change f of x for negative x, this is negative x squared. You know, okay, this is equivalent to say negative 1 squared and x squared, no? And negative 1 squared is positive 1 or invisible. And you see, wow, look at that. The function stays the same. Nothing changed. The reason is because the interpretation, the geometric interpretation, this idea is because I know very well that function is a parabola like that. And the parabola, if you perform reflection about the y-axis, stay the same. Because basically the thing we are doing is try to rotate like that. Just stay the same. Okay? This is definition even. Entonces, en conclusion, it's a noise. In conclusion, let me see who have the microphone open. Come on, guys, putting off the microphone. Ay. A ver, let me see. Hi, Professor, I'm sorry to be late. No, it's okay. It's okay, Christine. A ver, let me see.
Thank you, I'm sorry.
No, it's okay. Okay, let me check the microphone for everyone. Okay. It's my microphone. No, and Daniel putting off the microphone. Okay. It's okay. Just continue, guys. No distraction. Today is a complicated day. Okay. So do you understand what the idea even function? Even function. How you prove mathematically, algebraically, it's even function? Well, let me try another example. Suppose g of x is equal x to the 4th power plus absolute value x. I need to prove that this is even or not. Okay. We're doing reflection. Reflection is replace x for negative x. Yeah, I know. When the exponent is even, this is the reason this is called even. No? Stay the same. And absolute value of negative number is equal to absolute value of positive number. And we compare this and this. Wow, same. Therefore, conclusion, that function is even. and that function is even. Y si es even, automatically, I know que es symmetric with respect y-axis and the story. So suppose I have no idea. I put in decimal maybe to want to see, but suppose that this is the function and the function look like that in the x part, in the positive part of the x. So now in the negative part of the x is exactly the same. Like that. Boom. That is the reason, okay, as for is even function. Do you follow me? Even function, replace x for negative x, make a reflection, and nothing happened. Why? Because it's symmetric. And odd, no, odd is different. Odd is different. Odd is different. Odd is, you know, definition. This was definition. Definition of the of is. You, for example, replace x for negative x. And this is negative but outside. It's like a wow. What is the interpretation? It's like a one reflection about y-axis is equal another reflection about the x-axis. This is one possibility. Or another interpretation is you, for example, you are doing double reflection. So when you are doing double reflection, the function stays the same. Because this negative, if you want, you put here negative f minus x is equal to the original function. Okay, I don't know what is the best way to interpret it. This is a definition. This is the formal definition. However, to see geometrically, I propose you this idea, no? Double reflection about y or a reflection about x. This is the function. Wow, magically stay the same. Okay, example of this one. Okay. Example is the cubic function, for example. Any power function that the exponent is odd, like a 5, like a 7, like a 3, is odd function. It's obvious. It's the only no. There are a lot of collections. In the review, you see more interesting. This is just the basic idea. How you prove algebraically? Why don't you replace x for negative x? And let's see what happens. Negative x cubic is equivalent to say negative 1 cubic and x cubic. Here negative 1 cubic, I know it's negative 1, so it's negative x cubic. And we compare this and the original. Wow. No, it's not the same. No. It's completely opposite sign. Therefore, it's odd. Okay? How you see geometrically the idea? Well, cubic function look like that. You know. Let's use in this idea. Double reflection. You're reflecting first, according to the order of operation inside the parenthesis first. You're reflecting about the y-axis because you know that when you change x for negative x, the reflection is like that. Okay? This guy is x cubed. This guy is negative x cubed. However, when you are doing another reflection, you put a negative here, is negative, double negative become positive, and we come back again to the regular. You see? What about neither? No, neither is the most popular. The majority of the functions are neither, because no especial. Entonces, how you create, for example, neither function? Easy. Suppose that you combine one function like that, h of x equal x squared, que I know que es even, plus x cubed, que I know que es odd. And the combination even and odd is obvious neither. How you prove? Well, okay, you change x for negative x. I know this stays the same because this is even, but this no, it's change the sign. When you compare this and this, so completely different. So we have two possibilities. Same same twin brother is even. Opposite sign is odd. But this case no is, you know, it's a mixed. It's the combination. The x part stays the same, but the other no doesn't hit. And it have no symmetric. It's completely ordinary. One more example. Suppose the function m of x is equal. Suppose. Let me see one interesting example. X cubed plus 2 or plus 3. Gets confusing. Another example is suppose p of x is x to the 5th power, x to the 3rd power, x to the 1 power is invisible 1 upon plus 4. Entonces es obvio que this part alone is odd. But this part I don't have idea. As you see, 3 es obvio que es odd number, no? I put intentionally to confuse you. But actually, the function y equal 3 represents horizontal line. 1, 2, 3, a line like that. A horizontal line is obvious que es even function because it's symmetric with respect to y. Regardless, que es 3, que es 4, any number, right? Es horizontal. Any horizontal line, o sea, que not depending of x. And the combination is neither. This is odd. Wow, nice. This is odd. No, see, everything is odd. It's odd. It's obvious. But again, we have a constant function that's tricky. It's even. Because of 4, suppose 45. 45 is a number. It's a horizontal line in 45. Now this is even. So therefore, it's neither. You understand this or no? Sure? Clear? Confusing? Go ahead. Go ahead. Speak loudly and clear.
When you say like how do you automatically know it's odd? Like I'm still lost there. Like when you just look at it and just know it's odd.
Repeat it again, please. Because your audio is no good. I hear you intermittent. But. Come on. Go ahead. I pay my attention. Yeah, I hear. A little bit.
How do you automatically know that it's odd? Like when you look at it.
Good question. Automatically, I know because I know that any power function raised to the odd exponent is odd.
Raised to the what exponent?
To the odd number exponent.
Oh, okay.
5, 7. However, x to the even exponent is even function. Making sense, right?
Got it.
Okay, let's move on to the review. Yeah, we start review. No more blah. Okay, let me upload the document. I sent again for you, right? I sent the last time. Yeah, I send now the document. Select the page, insert the page, this page. Okay, let's focus on the question number 1. Question number 1 has 2 questions. Well, only one, sorry. Can determine the interval over the function is increasing, decreasing, and constant. Write your answer in interval notation. This is important. You seek any answer of the interval that you write in the test. Always, anytime, you need to express it in interval notation. Okay, I try to do a rough sketch of this. X, Y. This look like a parabola, but a parabola open down. That point is the point 0,7. This point is the point 4,0. And this point is negative 4,0. Actually, this is super easy question. However, the student failed. Why? Because the confusing part is que the interval que I asked you, determine the interval, you need to express it in x value. O sea, intervalue es x value because x value is the value of the domain. Okay, so in this case, I can see que from, so this arrow indicate que this parabola continue forever in that direction, no? So I don't care that part. However, I can see, I don't know if you see or no, que in this interval, my function is increasing. O sea, from negative infinity to 0, no increase 0 because 0 is the local max. Okay, I don't care that part. The function is increasing. Look at that, look at that. This is the roller coaster car, always walking from left to right, and this car is moving upward. Okay, and here in 0 stop. Entonces, this information, I know that. This information, the y value, like this, for example, like this 0, 7, and 0 is completely irrelevant. It's information que is given in the graph to confuse you. The important thing is the domain. It's x value, it's the first component. So the important thing is -4, 0, and 4. But actually, the most important is 0, because 0 is the transition point in which the function here stop increasing, not increasing anymore. This is increasing, capital I. And from 0 to positive infinity, the function is decreasing. And constant, never. Never, because you don't see that the function stays constant, no? We have no flat part in this example. Any question, guys? Remember, this is a review. This is important that you understand. In the test, I promise that you can face questions very, very similar to this. Entonces the student, no, increasing, I understand increasing from negative infinity to 7. Wrong. This is x value. This is x value. The x value is 0, not 7. Do you understand or no? I repeat again. Is it necessary?
Decreasing, it would just be the opposite side?
Opposite side? No. Decreasing is when the roller coaster car can travel on the curve is going down, decreasing.
Yeah, that's like on the opposite side, on the other side.
Well, okay. It's your, okay, I use the formal mathematical terminology. Okay. Listen, increasing is, the roller coaster is imaginary tool que I use to illustrate the idea, is the motion and the x value. In the x-axis. However, see, when you're moving from left to right, you can see that inside our interval, the y is going up, so increasing. Suppose I go to 5 to 7, or I go to the -1 to +2, increasing is going up, because the function is increasing specifically in this interval. And decreasing, when you move from left to right in the x direction, the y direction decreasing. O sea, the value decreasing is less than. So suppose I go from 7 to 4 or from to -4. Decreasing. Let me see. Then, so now let me highlight decreasing interval in green color is this interval. O sea, decreasing green, increasing blue. Constant, never. And that function. I know that this is easy. What is the challenge? I'm teaching this subject infinity time. Not infinity, but 1,000 times. And I saw when I grade the test, the mistake is that the student expresses the interval using y value. No, coño. No y, x, only x, x value, que es the domain. Any question? Any question? No? Remember, this is a review. I have all the time of my life to explain this. No problema. All right, zoom up. Give me a signal. I understand, professor. Zoom up, zoom down. Eso, bueno. Okay, good. Let's move on to the question 2, que es similar. Very, very similar. Boom. Wow. Boom. Okay. Let me try to do the rough sketch for the question 2. Question 2 is a little bit more complicated. A little bit more complicated. Suppose the curve look like that. Now remember, this arrow indicates it continue forever in that direction. It's go up and it's going down. So this point is given. Okay, I respect that. The x is a negative 0.5. No y value. Nice. I like that. And this is 0.5. So now again the three things that they want: increasing, decreasing, constant. Help me. Could you help me or no? Remember, our domain is from negative infinity to positive infinity. I suppose that. Because I cannot see any hole, any gap. This is my domain. But I need to specification inside the domain where the part gets increasing, where the part gets decreasing, and where the part gets constant. For example, in that part, it's a roller coaster car. It's going down, ¿no? Entonces, ¿es decreasing o no? Es decreasing. Guy, who's on the chat? Or activate the microphone. Es, do you understand this, Mister?
Yes.
Absolutely. Entonces, es decreasing, this interval. How you express this interval? Well, I express this interval like that. Look, this is from negative infinity, comma, negative 0.5. And we have another part that's decreasing. Yes, I suppose. That so part.
Wouldn't that go into decreasing?
Sorry. Thank you. Decreasing. Let me change the letter. Decreasing. Decreasing. You're right. Increasing. Guys, anything I make a mistake, you let me know. Okay, so this is, I continue the decreasing part. I can see in that part is also decreasing. Yes or no? And we have another interval that decreases. See, like that. This is union, 0.5 positive, comma, infinity. End the story. This is decreasing interval. And what about the interval in between negative 0.5 and positive 0.5? Es obvio que es increasing because in this case it's going up. El roller coaster car is going up. Entonces this is increasing. Look, increasing. We never include the endpoint because of the local. In this case, local mean is this guy, and it's the local one. Okay, the transition point in which change from increasing to decreasing or backward. And constant never in this specific example because I don't see any region can behave flat. It's a constant. Flat, look at that. No, never happened in that situation. This is it. Any question? 1 and 2 we are doing. How do you feel in that part? Was in the test or prior? Graphic? It's a question 1. And you determine the interval that the function is increasing, decreasing, or constant. And express it always the interval n interval notation. Any question? Any question?
No.
Okay. Super. I like that. Number 3 is a piecewise function. Piecewise defined function. Okay, I want to copy f of x is equal. We have 3 pieces, minus 3x plus 2. And this piece is valid if the x that you want to evaluate is less than negative 2. X squared plus 1 if the x is in between negative 2 and positive 3. But include a negative 2, I put an equal sign. This equal is extremely important. Okay. All right, let me see. Negative 2 less than or equal x less than 3. So I include negative 2, but don't include 3. And 4 is a constant function if x is greater than or equal to 3, include 3. And you need to evaluate negative 2, 0. No. Let me copy down. Let me copy down. 0. Because I need a space to manipulate here. 3. This doesn't matter. The order is irrelevant. Okay, let's zoom. Negative 3. 5 and negative 4. Entonces, the idea is easy. The idea is, this is the x value, okay? Want to evaluate. You try to find in the interval in which this value is inside, that belong to the what interval. So we have, let me put here 3 colors: blue, green, and yellow. And you let me know the interval you believe it belong to negative 2. What interval you believe it belong negative 2? In the blue, in the green, or in the yellow? Huh? You have no idea what is my question? My question is, in this example, number 1, I know that x is equal to negative 2. So I need to selection. So the piecewise function have 3 pieces, and you select what piece you use according to the interval that lie negative 2. Lie in the first, lie in the second, or lie in the third. Help me. Blue, green, or yellow? Hey, what's going on? Green. Absolutely. Green. You're right. You're right. This is confusing. I know. It's confusing because we have 2 here, negative 2, and negative 2. But I make a decision. What is negative 2 in the blue part or negative 2 in the green part? No, in the green because it's equal. Entonces negative 2 belong to this interval, green interval. Therefore, I select the green expression. Is this. And you plug it in a negative 2 into the expression. Negative 2 squared plus 1. Negative 2 squared is positive 4, plus 1 is positive 5. Done. End the story. Super easy. So the process is discover what x value here belong in what interval. You select the piece that corresponds with the interval, and plugging in that value into the function. Okay, this is yellow. Okay. Who help me with the 0? Who help me with the 0? Come on, help me. What piece I select? Blue, green, or yellow?
Green.
Absolutely perfect. Green again, this is x squared plus 1, but now you evaluate at 0. 0 squared plus 1 is 1. Done. End the story. What about 3? What about x equal 3? What belong to the green, yellow, blue?
Yellow.
Absolutely. And yellow, the expression is just 4. It's an expression that do not depending of x. Go ahead, the answer is 4. Anything. Negative 3. Now, it's the turn. Negative 3 belong to the what? Belong to the yellow, green, or blue?
Blue.
Say again, yellow.
Blue.
Blue, you're right, blue. Blue because, okay, one fantastic way to see that you mentally plugging in x equal minus 3, less than minus 2. This statement is obvious, it's true, no? You are doing mentally. Entonces, blue, 3x plus 2. Evaluate at x equal minus 3. So minus 3 times minus 3, be careful with the sign, plus 2, this is 9, plus 2, 11. So positive 9, plus 2, 11. What about 5? Green, blue, or yellow?
Yellow.
Yellow, and yellow is easy, because yellow the expression is 4. Similar to the 3. Blue, green, or yellow? Hey, what's going on?
Blue.
Negative 4. Blue. So again, I select the expression in blue that corresponding with the condition because negative 4 is less than negative 2, and you evaluate at negative 4. It's negative 3 times negative 4 plus 2. This is 12 positive plus 2. Come on, guys, this is a moment. In the test, I cannot do anything for you, but in the review, yes. Okay? The part that you want to repeat again, it's easy because it's just discover the x value is given. You discover in what interval lie, and this allow me make a selection, the expression, and just plug it in here. Clear? Confusing? Confusing? Clear? Come on, I want to hear opinion. Easy. One easy of these you see in the test. What's going on? Doesn't work this, carajo. What? Let me try to see this working now. You know. Good. Let's move on to number 4. Well, number 4 is different because number 4 is do the graph. And do the graph is always complicated. But don't worry, be happy. Let me try. For example, you can do in Desmos. In this case, I want to do by hand. But if you want, we are doing it both using this one. I have here one image to help me to create the rectangular system XY axis. Okay. Entonces, the piecewise function is defined by 2 pieces. One piece I put in yellow color, another piece I put in blue color. And this corresponds with the function y equal minus 3 plus x. And the y equal 4, because this is a y value, no? Because it's f of x, and you know that f of x and y is the same thing. But this is AC, this is a constant function, and negative 4 here, horizontal line. Let me use the rule. I put 0 degree because it's horizontal, 0 degree. 1, 2, 0, horizontal. 9. Let me use one color, maybe yellow is good. Okay, the final answer should be black. Okay, now for the second Okay, I need to say put it the one label to identification. This is y equal 4 because I don't want. It's hard to forget, but I put a label. Okay, the second fy equal -3. Okay, just in this case I prefer write like that. X minus 3. Oh, it's easy because I know the line equation is mx plus b. Okay, I plot that point here on the y-axis, and its slope is 1. And it does, then, when its slope is 1, I suppose the wrong and right both are 1. Okay, so from this point I go up 1 because the slope is positive. And 1 up, I go from -3 to positive to -2, sorry, and 1 to the right is 1. So I determine the second point is this. And we connecting by the line, using the rule one more time. By the way, the angle is 45 degrees because the slope is 1. Out. 45 degrees. Boom. I connect to this point. Okay, using maybe blue line. Okay. And thus I want to see much better. Make a zoom. This line gets the blue corresponding with the equation y equal -3 plus x. Okay, the second piece. The second, no. The first piece of the my piecewise function. Okay, at least I am doing this graph and this graph completely independent, separately. Now I want to connect it. I want to connect it now. But to connect it, I need the transition line. What is the transition line? The transition point is the condition. I know that that's change in 1. That 1 is important point. This is important point. Let me use it red color. Important point 1. Because I am doing a vertical dotted line. See, this is vertical, just a 90 degree. 90 degree. Vertical dotted line. Passing through 1. What is the reason it's dotted line? Because this is only one reference to see how the piecewise function split the plane into semi-plane. We have the plane to the right and you have the plane to the left. Basically, this is left because it's left down and it's a right. Okay, this is 4. Now I went to using black color. Bold black color. Okay. To the right is valid the constant function, that's 4. And it continues forever. Boom. This is my graph. Actually, this is my final answer. Okay, corresponds to that part. And that part is the other piece. Okay, it's from -infinity, travel on the blue line and stop here because I know that 1 change left right. This is important, super important. We have 2 special points. So in the test, you need to put a special point. One is empty, another is full. How do you know full or empty? Depending on the equal sign. Equal sign is N4, and this is empty. Empty is like that. Boom. Okay, like that. Actually, my graph is, if you want, no strictly necessary, delete the rest of the, complementary construction can help me to understand the piecewise function. It's a complementary. Actually, my piecewise function is only the black part. Only the black part. Okay, important thing. So what is the procedure? Number one step is do separately. Do separately. Do separately. the graph of 2 or 3 pieces, the pieces in plural. A problem in the test, in this question we have only 2 pieces. And no big deal. No parabola, line, constant, easy, no big deal. This is the step 1. Step 2 is do the transition. Transition, vertical line. Where? In the number, no? That we have in this case 1, but in the test I have no idea. Si es 1, si es 2, si es 3, or si es 2. Bueno, no, it's 1 because it's 2 pieces. 2 pieces, 1 transition. Okay, 2 pieces, 1 transition. And number 3 is, bueno, do the graph with selections, the corresponding pieces. What is that in common English? You know, when I write something, it's blah blah blah. You say I don't understand very well in mathematics. Okay, you determine who is left and who is right. So left, right. It's obvious that left is less than, no? Right is greater than. An important thing that you cannot forget is the points. So let me call transition or the connecting point, whatever you want. The endpoints. See, the circle is full or it's empty. Remember, there are 2 possibilities. Possibility is full empty. I don't know if it's like that or like that. It's the same, no? This is possible. This is also possible. Both empty because it's undefined in both. Suppose I change the problem. I put x less than 1 and x greater than 1. I delete the equal sign to say something like that. Both empty. But this is possible. Possibility number 1. This is possibility number 2. And possibility number 3 is impossible. It's full. Because this is a contradiction with the function. Remember, 1x is impossible to have 2 different y. This is illegal. It's not function. Everyone follow me? Complicated or easy? Come on, opinions. Guys, today is important day. Good. Today is important day. I don't care. See, I need to repeat, explain in different way. The most important for me is that you understand very well. And you, when you see the test, you say, wow, it's a piece of cake for me. Okay? Okay. So let me erase. We are doing number 5 question. Out. I do a stupid thing. I close the. Okay, no problem. I close the whiteboard. I open new one. Okay, there you go. No, here. Okay, super. Because I need to erase everything. Boom. This one and this one. It's completely different. It does not belong to this. The question 5 say, let me see. The question 5 say, do the graph of the function. This is important, guy. I know it's easy, but it's important. Do the graph of the function f of x is equal minus x squared plus 4. And also find y in a set and x in a set. So this is an important point to do the graph. But first of all, I need to understand the transformation. So this function gets given in our problem.
I think that the switch the screen.
Ah, sorry. Sorry. Now let me see. Boom. Now?
Yes.
Okay, good. Good. Okay. So I repeat again. And we're doing number 5. And number 5, one function is given. And the question say, do the graph. And the question say, important thing, find y-intercept and x-intercept. It's a specific point. Okay, Dylan. Okay, so now I need to know okay, this graph is a family of the function x squared, que es de parábola, ¿no? Parábola look like that. Roughly sketch. It's a base graph. But we can see here minus a reflection. Okay, but what kind of reflection? This is x squared. This is minus x squared. It's a reflection. And reflection look like that. Boom. Pero reflection about x-axis. Okay. And plus 4 is a minus x squared plus 4. It's a vertical shift 4 unit up. So my parabola now is 1, 2, 3, 4. That the vertex of the parabola that normally is in 0,0, and when you change the sign, it stays the same. Now change to 0,4, and the parabola open up. It's a roughly case. After we are doing more clear. Do you understand the transformation? So the transformation is transformation number 1, reflection. Transformation number 2, vertical shift, 4 unit up. This is clear or confusing?
Clear.
Therefore,
Clear.
I have almost 100% the information because I know that the parabola, but the parabola open down because negative is reflection, and also the vertex is located at the point 0,4. Okay, by the way, is the y-intercept. Okay, I have good information so far. Now I go directly to the point to find the x-intercept and y-intercept. Professor, what is the formula? What is the formula to find y-intercept and x-intercept? I don't remember. One is easy. Using the function notation, you evaluate in 0. So you evaluate in 0. The value that you get here is the y-intercept. Let's do it. It's minus 0 squared plus 4. 0 squared is 0. I don't care the sign negative because 0 has no sign. The answer is 4. Therefore, the 0.4 point is the y-intercept. In other words, y-intercept is the point when the curve crosses the y-axis. 0,4. And what about x-intercept? What is the formula, Professor, for finding x-intercept? Well, no, it's similar. You put f of x and you enforce it to be 0 but the y value. Guys, keep in mind this formula because we are using it throughout the semester. Formula for the y-intercept. Top. Formula for the y-intercept. But this in this case is a little bit more complicated because f of x is minus x squared plus 4. And you enforce it to be 0. In this moment, you have quadratic equation. And you solve the quadratic equation. How? Well, by square root method. So you bring down x squared. I move 4 to the other side. Divided by -1. Because I don't like the negative sign. Apply a square root both sides. X is equal plus and minus 2. Don't forget plus and minus. You have two intercept. You have two y-intercept. It's exactly expecting is 2,0 and negative 2,0. Why? It's expecting because the parabola up and down. And I suppose that the parabola crossed the x-axis in 2 points. Let me try to do now more elegant sketch of the parabola in this example. Here. You plot the point. You plot the point. 0,4 here. That guy here. Y intercept. This guy, negative 2,0, positive 2,0. This guy is this guy, and this guy is this guy. So now approximately my parabola look like that. Remember the parabola. Don't do the parabola like that, guy, because the parabola have not that corner. The parabola is a smooth curve like that, and this continues forever. Boom, in that direction. Boom, in that direction. And this is the graph they want. The graph of this. Question. How do you feel? How do you feel?
Feel pretty good.
Excellent. Okay, how do you feel? Really good. Okay, let's move on to the second page. The second page of the review. Guys, we are doing slow down because we have time. I'm planning to have time to repeat, reinforcing the concept. Okay, let me try to upload PDF, the second page. Okay, there you go, look at that, second page. Second page. And the second page asked me in the number 6 question. It's similar to number 5 we did before. 6, do the graph. Using transformation. Oh, more clear now. Of the function that they call g. And the function g is minus x plus 2. This is weird. This is really big weird. Remember, sometimes it's not clear to see the transformation and the expression gets given. You need to do something sometime. This is a case. You need to do something. The something I propose you algebra to do is you factorization -1 outside, and you have x minus 2 like that. Let me check it out, see this is equivalent to this or no. Negative and positive and negative. Negative and negative is positive. Oh yes, it's the same. Okay, but in my opinion, it's more clear to see the transformation that you have to apply in that case. Well, this function, both, by the way, it's the same, it's equivalent, they are equivalent, it's the same thing, pero expressed in it's equivalent, it's equivalent, it's the same. Belong to the family of the function square root. This is the basic function without transformation. And the basic function I know is like that. Boom. Now I need help. Help me to see the transformation. I saw two transformations. Transformation 1 and transformation 2, and this is important to visualize the order. What is the first one? What is the second one? Okay, we have compare this. Is the basic without transformation, and this okay, is the new one with transformation. What transformation you can see? I need to classify an A, in what direction move, stretching, compressing, reflection, whatever, can you know? Help me, guy. What is the first transformation, in your opinion?
Reflection.
Exactly. Exactly. Exactly, because this negative here indicate me reflection. But what kind of reflection, mister? Because you have two reflections. Remember, we have reflection about y, or you have reflection about x.
About Y.
Okay, by the way, let me recall about y. Very well. About y. About y. Okay. Let me recall. So you change the sign inside the parentheses, it's about y. So you change the sign outside the parentheses, it's about x. Entonces, about y, I know que the reflection is, let me try to change a little bit the position of that graph. Let me move a little bit, not too much, in that direction. So this is the graph of the radical x. Of the radical x without transformation. After we perform the first transformation, que es negative, que es reflection, my graph now change like that. I did the first transformation number 1. And what about the second one? And what about the second one? The second transformation that you see here in this expression. I need to classify. It's compressing, stretching, reflection again, shift, horizontal shift, vertical shift. What about this? Opinion.
It's gonna shift to the right.
Exactly. Very well. Exactly. Es horizontal. Shift to the right. How many units? How many units? How many units? You move.
2 units.
Say again.
2 units.
2 units. Very well. So now my graph is moving now 2 units to the right. I suppose at this point I take the reference. That point is 1, 2 here. Change like that. Okay. And this is the graph that corresponds with the original x minus x plus 2. Do you understand this or no? But let's do it now in detail. Everyone follow me? No problema. Let's do it in detail. Detail now. I want to call to the image of the rectangular coordinate system. Okay, this one. Okay, boom. I want to call the image of the rectangular coordinate system. This one. Okay, I put in the middle of the page. Boom. Okay, so now my graph que is the red color, is in 2, no? I'm open, I have no idea in that direction. Yes or no? But I want the question, don't say explicit y and z and x and z, but we are doing like a reference. This is an important point when you are doing the graph. Any graph que I say do the graph, well, we are doing several things, but the important thing is the intercept. Remember the formulas for the y and z. Evaluate the function. Que la function de name is no f, es g. G and 0. Plugging in. Let's do it. Entonces, square root negative 0 plus 2 is radical 2. Now, radical 2, you put in the calculator, it's approximately 1.41. Ah, yeah, it's that point. That point is the point. That point is the point. 0, comma, radical 2. And the x in cell, the formula is g of x equal to 0. Entonces, who is g of x? The original equation gets given. I copy that and force it to be 0. Entonces, we have in front of the one radical equation. If you want to eliminate the radical, square both sides. Minus x plus 2. And 0 squared is 0. So minus x is equal to minus 2. And move 2 to the right hand side like a minus, divided by negative 1, both sides. X is 2. And the point is the point 2, 0. Okay, that point was 0, radical 2. And that point is 2, 0. It's exactly what we expect. 2, 0. End the story. Okay, finish. And the graph have no part here. No, because it's totally out of the domain. Any question? 2 questions like that you can see in the test. I promise. I promise. Transformation. No big deal. Similar to this. Okay. Boom. Okay. Doing now the number 7. Let me try to do something. And number 7, and we continue to, Tuesday, right? Remember, Tuesday, when I finish the review, I send the test, number 2. And we have 2 days to do that. So number 7 is easy. Wow, it's easy. Determine, so we have a collection of the different functions. So the first one is 3x squared plus x to the 6th power plus absolute value. The second is g is equal to x cubed plus x plus 1. This is the a, b, c is h of x is equal to x cubed over x squared plus 1. And the last one, the p of x is x squared over x squared plus 4. So they want you to determine algebraically, this is important word, algebraically, whether the given function are even odd or neither. Okay, I suspect that the first one is even because the exponent is even 2, 6, and absolute value. Just in case I want to prove, I make a reflection. Look, this is the algebraic way. You make a reflection about the y-axis. See, the function stay the same. It's because it's even. And it's obvious that yes, stay the same because when you raise a negative number to the even exponent, it's positive, and absolute value is also positive, and this is the same, doesn't change. Therefore, the conclusion of this function is here. Do you follow me? Do you follow me? Do you follow me in the first one? In the A?
Yep. Yes, sir.
Okay. Let's move on to the B. Exactly the same. Guy, I don't want to see another way. You are doing this. You make a reflection. Okay, replace x for negative x. And let's see what happens. Negative x cubed plus negative x plus 1. Well, I know when the exponent is odd number, it's negative. This is 1, it's also a negative. And it's plus 1. And we compare this and this. Wow. It's not the same. It's not even. But it's not completely opposite sign. Therefore, it's neither. To be odd, es que you have, suppose, another example, I don't know, que es minus here. Entonces, odd. But in this case, no. Because this is a constant, do not depending on x. And stay the same positive. And the first is negative, opposite, good. Good candidate to be odd. The second is negative. Oh, okay, good. Turns out to be odd. And the second, no, because it's the same sign, not opposite sign. Okay, no twin brother, no even. Twin brother is even. No brother and sister. Okay, es, you know, es a mix. Entonces es neither. No especie. Do you follow me? The idea for the neither. Okay, si it's no twin brother or completely opposite sign, es neither. This is very, very confusing. Pay attention, please. Surprise. It's a negative x cubic divided by negative x squared plus 1. Yeah, you know that when the exponent is odd number, it's negative. And when the exponent is even, it's positive. However, listen, to make a decision, it's always even, it's not even, because you have one extra negative. But in order to compare this expression and this expression, you consider like a fraction and you put a minus outside. And we compare this and this. The definition for the odd function. The odd function, when you replace x for negative x, you give me negative h of x. So this is the original. Look at that. And this negative extra outside, this is obvious odd function. Yes or no? Yes or no?
Yes, yes.
Okay, good. This is tricky. Some students say, no, it's neither, because the top part is negative and the bottom part is positive. I need, you say, professor, que es completely opposite sign. No, completely opposite sign, the entire expression. As you can see, like a fraction, you know, when you have negative 5 over 4, it's equivalent to, say, negative 5 over 4, or positive 5 over negative 4. This is equivalent, no? So this negative in the fraction, you move in the place that you want. You put in the top, you put in the bottom, or you put in the middle, because it's more elegant. Okay? Let's do it in the last one, and that's it for today. P. What about P? P reflection is minus x squared divided by minus x squared plus 4. And you know, because the exponent is even, is positive. Wow. And we compare this and this, it's the same. Therefore, it's even. Any question? Any question? No? Everything's clear? Sure? No problema? Okay, entonces we continue. As always, I repeat again, you need tutoring,